All right, so in this example, we're going to look at the needed sample size to meet certain conditions, particularly margin of error, right? So this one, you want to estimate the mean lifespan of electronic components made by a certain manufacturer. How many components must you sample if you want to be 99% confident that the sample mean lifespan is within 3 hours of the true mean? And you're told to assume that sigma is 20 hours. All right. So again, here, the only hard part about these problems is making sure that you're actually reading them to figure out, hey, what are you being asked to find, right? How many components must you sample means find n. Find the sample size, right? Now, what do we know? We know, so given, let's make that look a little bit nicer. We want 99% confidence. So that means, so this is means, and we know what the standard deviation of the population is. It's 20 hours. So we know we're doing a z-score, right? So 99%, 2.576. Okay. And we're also, let's see, so we've used the 99%. What about the within 3 hours? So this tells us our margin of error. Right? And we're told what sigma is. Okay. Now, and hopefully you remember that the formula for sample size for a mean, right, was what? Z sigma over margin of error, whole thing squared. Right? And this is coming, again, from, remember, the margin of error is everything after the plus minus, right? Z sigma over root n. So we could say, okay, great, that's root n times margin of error equals z sigma, right? Just multiply both sides by square root of n, divide both sides by margin of error, and then, of course, square both sides. And we've got our formula. Okay, so, but we're just plugging and chugging here, right? We know z, 2.576. We know sigma, 20. We know the margin of error is 3, and we're squaring that whole thing. And so that we've got to go throw into our calculator, which we'll do here. All right, so what do we have? We had 2.576 and our 20. All right, so 2.576 times 20 over 3, and that whole thing gets squared. So we are looking at 294.92. Which means, of course, we need to round because we can't sample 0.92 of a component, right? And this one does follow regular rounding rules. So we're going to go 295 components is what we need to sample. There we go. That's actually the end of that problem.